Hello, Assalamualaikum. So we now proceed to the next part, which is the line and double line to ground fault. Okay, without further ado, let's go to the main contents. So I hope you can understand. Okay, alright. Under the graduated with line to line fault, what is different between the single line to ground? The several difference here. One is the phase C and phase B are connected. So this is connected. Okay, this is connected. Because this is connected, IB equal to minus IC. And then what is next? The IN here is equal to 0. So when IN here equal to 0, sorry, this is IA. And the IA is 0. So the IA is 0. Okay. What others? So VB, okay, VB equal to VC. Okay, that's the difference between the single line to ground. Okay, so basically this is the general equation that we use in the fault analysis. You always see it many times. Okay, and then one is the positive and the negative sequence of VA is the same value. Okay, which is VA1 equal to VA2. Okay. So this is it. What should we do? So basically, basic symmetrical components of the currents. So IA0, IA1, IA2, and then like I told you, the IA already was 0. So this IA equal to 0. And because the IC equal to negative IB, that's why IB here, this is equal IB equal to minus IC. Okay, from here you can just multiply it. Okay, just solve this matrix, and you're going to get the IA equal to 0. Okay, IA2 equal to IA1, and you get VA equal to 0. Then after that, we are going to use the same equation as before, which is this basic general equation, same with the single line to ground. Okay, please refer SLG, single line to ground slide. Okay. Then we have the case of things. So what you're going to do, you're going to replace the value that mentioned here. For example, this one equal to 0, and VA0 equal to 0, and then VA2 equal to IA2 equal to minus IA1. Okay, IA2 equal to minus IA1. So IA2 now is minus IA1. So that you're going to get this matrix. Okay, this matrix with the IB IA1 and minus IA1, while the VA0 is 0 here. Then we proceed solve the matrix. So we continue to solve the matrix. Oh, sorry, it's coming out suddenly. So from here you solve the matrix. You solve the matrix. You minus everything. Okay, so the matrix. So the A1. So you get VA1 equals to EA minus IA1 Z1. So this one's equation. And then VA2 equal to 0 minus minus Z2 IA1. So you get the second one here. Then because like I told you, because the VA1 equal to VA2, our first agreement here. Okay, this part. So VA1 equal to VA2, and then that's why you solve the problem. Okay, solve problem, and finally you get the IA1 equal to EA over Z1 plus Z2. What about the SLG? SLG, the difference only this. IA1 equal to what? I'm sure you remember, Z1 plus Z2 plus Z0. So this is IA1 for the SLG. But for this time is for the LL. Okay, for the LL line to line is the EA over Z1 plus Z2. Okay, so basically how to connect it, how to draw it for the case of a line to line. So the positive and negative sequences network are connected in parallel. So no zero sequence here. No zero sequence here. Only positive and negative sequence are included. So remember, positive, this is part for positive and this is part for negative. Okay. So don't forget the generator. For positive you have the generator, and for negative without the generator, and this part is connected to reactance is connected here, and for the generator part is connected here. So that's why it's parallel. So basically this is the equation that you're going to memorize it. Okay, it's very easy. Okay, very easy. So the fault current finally, IB equal to minus IC. So in this expression, it's a 2 times 2 minus A2 minus A multiplied with IA1, you get minus J root 3 IA1. So this fixed already. You can refer to Hadis Sadat book also. Okay, alright. Let's jump to the example. The example is almost the same like previous. I don't know why, but it's okay. 115 VA base and 13.8 kilovolt is the voltage base. One square generator has reactance, positive, negative. So positive 20%, negative 10%, and 0 is 5%. Okay, 0 is 5%. So the neutral generator is solidly grounded, and generator is connected to short transmission line. So transmission line have positive and negative sequence, reactance of 10%. So it means that positive and negative 10%. And zero sequence impedance is 30%. So 0x0 is XL0 maybe equal 0.3, 30% per unit. Okay. And then the generator was understood when a line to line. So the question here is line to line. Before this, single line to ground. Okay. Line to line occurs on phase A at the end of the line. So find the voltages and fault current at the fault point and at the generator terminal. So from here what we can imagine is the clue is, I don't know why, but suddenly it's coming out like this. So Z1 plus Z2. Okay, alright. Then, so basically this is the drawing. Okay, this is the image of the questions as interpreted in single line diagram. So we have the one. So positive sequence, negative sequence, and zero sequence, 0.2, 0.1, and 0.05. And then both positive and negative are the same, 0.1 per unit, and x0 is 0.3 per unit. So what's next? We draw the single diagram. Remember, it's parallel. So when it's parallel, it's very easy. You just cross it, this one to this. So generator to generator, even if it's not here. So we connect it here. So we are crossing to each other. Okay. So this one, just put the value 0.2 and the second is 0.1. What about the zero impedance? Because for the case of line to lines, the zero impedance network is totally eliminated, so we just consider only positive and negative sequence impedance network only. That's why 0.2, 0.1, okay, 0.2, 0.1, and 0.1 and 0.1, 0.1 and 0.1. Okay. So next, what should we do? As usual, we find the IA1 that I told you. It's very easy. EA Z1 plus Z2. So because the value is not given, basically this is a very basic assumption that we do for the initial value, which is EA equal 1.0 and the phase is 0. So solve the problem, then we get this is total for Z1, total for Z2. Z1 is 0.3 and Z2 is 0.2. Then you solve the problem and you're going to get the minus J 2.0 per unit is the value of the IA1. And then please be remember, we know already because the IA1 equal to minus IA2. Okay. So IA1 equals to minus IA2, and then we get the value of the IA2 actually. This is IA2. So IA1 you get the minus J, so this is actually the IA2. Oh wait, this is IA2 equal to minus IA1. So that's why we get the J 2.0 per unit. While the IA0 mentioned already, we know already is equal to 0. Okay. Alright. So then so what minus IA2, so minus IA2 is here. Okay, so this is basically we just substitute the value. So this is the IA1 and this is the IA2. So you just put the value, just substitute the value to get the phase current. Okay, phase current IA, IB, and IC. Okay. When we solve this part, we're going to get this per unit. Then we want the in kiloamps. Still remember how to write what should we do from per unit to kiloamps? What should we do? So we are going to do what? We are going to find what? The base current, the I base. How to go? The I base is MVA over the VL and root 3. Okay, MVA over the VL root 3. So here is 100 MVA and 3.8 kV, and it's root 3. Then I think we get something maybe around 6,000 something. I forgot. I forgot something like that. 6,000 amp something. 6,000 something. Maybe or 5,000. So when we get, sorry, please calculate it by yourself. And then after that, we just calculate with the I base, so that we get this value. So means that, so we are going to get the IB. So IB is minus 21.7 kilo amps, and the IC is 21.714 kiloamps. Right? Okay. So after that, for the first terminal voltage, what is the first terminal voltage? Maybe you get confused. Don't get confused. Very easy. This is the first terminal voltage. We mark already VTA1 and VTA2. Where's the VTA0? Remember, for this case, line to line, LL case 0 sequence. No zero sequence. So that's why VTA0 equal to 0. Then VTA1, where you get this thing? You need to remember. Very easy. So this is IA1 and the Z1. Okay. Okay, for this case, so this case, for this case is the IA2, IA2 Z1. Okay, so you just solve the part. Means because terminal, we are asking about terminal, so terminal from here to here only. This one total terminal until here. So between this and this, so until this level, so only 0.2. So J0.2. J0.2 is coming here. Okay. Okay. Oh, sorry, I forgot. It's minus. Okay, sorry. And then you solve the problem. You solve the equation. You get 0.6. We face 0 per unit, and then proceed for the VTA2, which is this one 0.1. Okay, and the IA2 is given already is 2.0. J2.0. For this case, IA1 is minus J2.0. Okay, then you get 0.2. Then for this case, we get the VTA. Same meaning with the VA1. Same, just the terminal. I mean the port that we take. Just the value for the terminal is different. The location of the point to the terminal is different. So just put this one is actually the VTA0. This is VTA1 and this is VTA2. Then the same equation we use until now. So use this matrix and you proceed. Okay, you just proceed with the values. Proceed the calculation, solve it, then you're going to get in per unit. Then after that, find the voltage base. Okay, you can refer the previous slide and previous subchapters to find it, and finally you're going to get this kind of values. Okay, all right.